everyone, in this video, I'm going to discuss the example for limits. Kindly refers to the question. Limit when x approaching 3. For the function, we have the x squared minus 8x plus with the 15 over the x minus 3. So if we substitute the value 3, and we will have 9 minus 24 plus with the 15, and we will obtain 0 over 0, where we call it indeterminate form. The suggested strategy would be multiply by the conjugate, factorize the situation, or long division. So in here, my suggestion would be factorize the situation. Limit when x approaching 3. If we factor the x squared minus 8x plus with the 15, and we will have x minus the 5, x minus the 3, over we have x minus 3. Notice that we have a common terms, so we can simplify the situation given. So rewrite the situation. So limit when x approaching 3. Then bracket, we have x minus the 5. So if we substitute the value 3, and we will have the value y approaching negative 2. Next, we have the situation. Limit when x approaching negative infinity. For the function, we have x squared plus 1 over the x cubed minus 2. If we substitute the value, and we will have positive infinity over the negative infinity, where we have the indeterminate form. The strategy will be dividing the highest power of the denominator. Highly refers to the numerator and also the denominator, and the highest power for the denominator will be x to the power of 3. So in here, my suggestion would be factor out the x to the power of 3. So if we factor out the x to the power of 3, then we will have 1 over the x, plus we have 1 over x to the power of 3, over, factor out the x to the power of 3, so we will have 1 minus 2 over x to the power of 3. So if we simplify, limit when x approaching negative infinity, we have 1 over x plus with 1 over x to the power of 3 over 1 minus 2 over x to the power of 3. So if we substitute, then we will obtain 0 over here, 0 over here, 0 over here. So finally, limit when x approaching negative infinity, x squared plus with the 1 over x to the power of 3 minus with the 2, then we will have 0 over 1, the value of y will be approaching 0. So this one we can call it horizontal asymptote, y is equals to 0 as well. Kindly refers to C. Limit when x approaching 1 from the left. For the function, we have the modulus 1 minus x over the 3x squared minus 4x plus with the 1. First of all, define the situation. We have modulus 1 minus x. Based on the definition, we have 1 minus x, negative bracket 1 minus x. With the domain x less than and equals to 1, x greater than 1. So that is the definition. So in here we have a number line. For the left hand side, we have 1 minus the x, included the 1 as well. And then for the right hand side, x greater than 1, we have negative bracket 1 minus x. So that is the definition. Limit when x approaching 1 from the left. So here we have the left hand side, 1 minus the x over, if we factor the situation, so here we will have 3x minus 1 multiplied with x minus 1. Rewrite the situation. Limit when x approaching 1 from the left, factor out the negative, and we have x minus 1 over, we have 3x minus 1, x minus 1. Simplify the situation. Limit when x approaching 1 from the left, we have negative 1 over 3x minus 1. So if we substitute the value, limit when x approaching 1 from the left, for the function modulus 1 minus x over, we have 3x squared minus 4x plus with the 1. The value of y will be approaching, if we substitute 1, we will have 3 minus 1, which is equals to negative 1 over 2. The value of y will be approaching negative 1 over 2.
If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.